On balance, I think that the AI will be a force for good, most likely, but the probability of it going bad is not 0%.
Yeah.
So we just need to mitigate the downside potential.
Hello there, I'm Gavin Freeborn, and this is Original Ideas, a podcast from the University of Liverpool. In this series, we're exploring academic research, the impact it has, the benefits it brings, and how research can shape society in the future. In the last episode, we looked at air pollution and heard about some brilliant research that's happening in the UK and around the world to improve air quality. But in this episode, we're focusing on something else that will impact every single one of us: AI.
What was interesting over the last couple of days, talking to everyone who's doing the development of this, is just the pace of advancement here is unlike anything all of you have seen in your careers in technology.
That's the UK Prime Minister Rishi Sunak speaking recently at the Global AI Summit in Bletchley Park, highlighting the wonderful benefits its application can bring to society, but with warnings on how we need to approach it responsibly. So in this episode of Original Ideas, we're going to explore the use of AI in research, the progress that we could make with it, and the issues that we need to consider. To start, we're going to meet Professor Andy Cooper and Professor Katie Atkinson from the University of Liverpool. In their own fields of chemistry and computer science, both Andy and Katie have conducted extensive research with the involvement of AI. I sat down with them both to find out more about the advantages of AI in research and the impact it could have over the next decade. So Katie, Andy, just before we start, could you tell us which academic area you specialise in and what your main research interests are?
Yes, hello, I'm Andy Cooper. I'm a professor of chemistry and my interests are materials chemistry and specifically the use of robots and AI to find new materials.
Hello, I'm Katie Atkinson. I'm a Professor of Computer Science and I'm Dean of the School of Electrical Engineering, Electronics and Computer Science. And my research is in the field of artificial intelligence, explainable AI, AI and law, and more recently, AI at the intersection of chemistry.
Excellent. So you're starting to work together. Wonderful. On to current projects. How are you using AI in your current projects and why?
So I work on the development of explainable artificial intelligence, and what that means is we want to be able to build decision support systems where they are helping humans in making decisions in one particular domain, and when they give a recommendation or an outcome, the AI algorithms are able to explain exactly why they came up with the particular outcome that they did and not some alternative outcome. And there's a lot of concern within the field of artificial intelligence at the moment about the use of so-called black box methods, and these are ones where the AI algorithms give you a solution but they can't tell you how or why they came up with that solution. What we're doing in my research is trying to open up that black box and make sure that all these systems that we're producing for real-world domains are going to be ones where the users can trust the outcomes of the system precisely because they've got this explainability. I specifically work in the field of AI and law, so that's building tools that can support legal professionals who are carrying out various different legal tasks. And what we do in our research at Liverpool is modelling legal reasoning. So we try to capture the reasoning that lawyers and judges undertake when they are deciding legal cases, and we build AI tools that can provide decision support to say, okay, we think the case should be decided in this particular way for the claimant or for the defendant and for this particular reason. And they're meant to be able to help with providing legally grounded justifications for the recommendations that are made by these systems.
Brilliant. Excellent, Katie. Thank you very much. And yourself, Andy?
Yes, so we're interested in discovering new materials that might be useful for society. One example would be catalysts which can make hydrogen gas as a clean fuel from water using sunlight. But the problem with that area is there are a very, very large number of possible catalysts, and it defines in the chemistry a very high dimensional space. So there may be 10, 20 or even perhaps 100 dimensions. And humans can't think much beyond 3 dimensions, so AI is particularly good at thinking or reasoning about things in high dimensional space. And more recently we've been applying this using autonomous robots. So these are robots which actually carry out experiments in laboratories, rather like a human. They move around the lab and they characterize the products, but the AI part is embedded in, as it were, the brain, and the robot can reason and make its own decisions about what to do next. So these things can work around the clock, 24/7, finding things, and the beautiful thing is you don't know what will come out of the end of the pipeline. So the robot can make a discovery and you don't know what it is. And we hope that these robots will find things that make a big difference to technologies such as energy production. And there are some synergies, because although this is chemistry, ultimately it's about making decisions. So as Katie works on decision making in law, there are decisions to be made in chemistry, in experiments, about what to do next. And although they sound like very different problems, from an AI perspective, actually they're strongly related.
Mm-hmm. Yeah, and I think that brings us on to the next question as well. There's a lot of talk about the responsibility of using AI, and thinking about the challenges of using it now and in the future. From my understanding of your chemist robots, they are programmed by humans, managed by humans, and have full control over them. But obviously, what they're doing brings forth multiplice results that humans could not get to.
Yeah, I mean, trustworthy AI is a big question. In chemistry specifically, it's a little different to areas that Katie mentioned earlier. So some people refer to AI as a jagged frontier, meaning that it's very good at some tasks and it's actually very, very poor and very low capabilities at others. So there's no prospect at the moment of a rogue AI robot making some dangerous chemical by itself. That just couldn't happen. So the sort of societal parts are more about safety in the lab and making sure that the robot operates in a safe way. Katie can speak more about the broader question, but for the chemistry lab, at least, it's a very well-controlled environment, so it's a different type of concern.
Excellent. Friendly, responsible robots. So, Katie, can you tell us a little bit more about, how you are involved in this responsible use of AI and how you deal with these conversations about people being cautious about it and the challenges that you see, and your connections as well to sort of European and global discussions around this?
Yeah, I mean, the technologies have been demonstrated to be highly effective and capable at certain tasks, but need to make sure that there's some regulation around their use and their deployment. And a lot of researchers working in this area would wholeheartedly agree with that. If you take, for instance, law, where we're building these tools to support with decision making, you still want to have the human in the loop, just like Andy mentioned in the chemistry setting as well. So we're not intending for these tools to be full replacements for human beings. They're meant to be systems that can help with the processing of information that's coming in, and in particular complex information that needs to be weighed up and reasoned about in a consistent manner, and then they produce recommendations that are presented for a human to make the final decision. And we also need to make a distinction between whatever domain you're working in. There are likely to be easy cases that are repeatable and that can be treated in a systematic way, and there's likely to be a set of difficult cases where the decision is less obvious at the start, and that's where you might need some more human input. So we really see the AI tools working side by side with the humans who are going to be deploying them, but ultimately helping them with their work. And if we've got these tools as well, that often will free up the time for legal professionals, taking away some of the drudgery and giving them some more time to interact with other people and doing the client-facing work that they're engaged in.
Excellent. So we're seeing more AI being used in academic research, and the University of Liverpool now has its own AI hub dedicated to developing AI use in chemistry. How will that help research in the future? And can you please tell us about your involvement? Andy, if you want to go first.
Well, as I'm sure everyone's aware, AI is developing at a really breakneck speed, and chemistry also actually is developing very quickly. So the core aim of the AI Hub is to bring together the leading edge of AI and the leading edge of chemistry in the UK, both in Liverpool but also outside of Liverpool. This hub is co-led by ourselves and Imperial College. It involves Cambridge University and the University of Southampton. So It's a national hub, and we're looking to bring together the best of those communities, because historically those communities haven't really spoken to each other. So we only began to work with AI in our labs in chemistry 5-6 years ago. Katie's been doing it for much longer than that. So we're looking to take the learning from the two disciplines, put it together.
So I think we've got some good groundwork established over the past few years through our collaboration to build on in the new hub. We've got joint projects, we've got joint PhD students, we've got new lecturers who are sitting at the interface of chemistry and computer science. So I think we've really made inroads into understanding each other's language. That's a key first step in interdisciplinary working, is making sure that you know the technical language, at least to give you entry into the other field. And I think we've done a lot of groundwork. There's no easy way of doing that. You've just got to collaborate and interact with the researchers on the other side, establish what the common language is and let each contribute its own expertise as well. And we've got a large group of researchers at Liverpool who are now working collaboratively, and we've really made great strides taking the best of what both departments can bring to this collaboration. There's been a lot of work internationally that started to look at AI for chemistry. A lot of it is based around machine learning. What we've brought at Liverpool is our expertise on the knowledge-based methods, symbolic AI and these explainable AI methods that I've already been talking about, and applying those to some of the chemistry methods to take forward the field of computational chemistry.
Excellent. And AI in the next decade, good or bad?
I'll go straight away and say I can't give a binary answer on that. It depends on how the technology is developed. It depends on how it's deployed. It depends upon how it's used. There's so many examples that you can look at in history where something new has come along. People have been frightened about it, been wanting to classify it into the good or bad category. But it really depends on many things. There's a lot of options for really great things to be achieved in AI, so discovery of new materials, like we've heard, supporting people like lawyers in doing their work and speeding up some of the processing of legal cases like we've been talking about. There's an awful lot of work going on the use of AI in medicine as well that has been shown to be really effective. So there's so many fields that have been touched by AI, but then there's obviously lots of questions that we should be asking ourselves about how this technology can be used for malign purposes. We need to be cautious about that. Cybersecurity issues are becoming more relevant. AI might be used for nefarious ends there as well. So lots of opportunities for good. We need to make sure that we're keeping an eye on the potential misuses as well, and making sure that as we roll out AI to be deployed in multiple different domains, that we've got the right regulatory frameworks to perform the checks and balances that are needed to make sure that we realise those benefits.
Thank you very much, Katie. And Andy, would you like to add anything?
Well, I pretty much agree with Katie. I think there are a number of things to be concerned about. I mean, deep fake videos is a well-known recent development, but you can easily imagine how very quickly people will develop AI applications to screen for those and tell you whether it's a deep fake. So this might be to some extent an arms race between sort of good and bad uses. But from a chemistry perspective, I think it's important to remember the scale of the challenges. To give just one quarter of the world's population lives without enough access to drinkable water. And we're beginning to work on new materials for harvesting water from the atmosphere. And that's something that these AI systems and robotic systems could assist with. So the wins are pretty big as well as the scare stories.
100%. Yeah, it strikes me it's a bit of a sort of Lord of the Rings situation. Whoever gets their hands on the ring, if they use it for good, all good, and if they don't, then it's a different story. So,
yeah, just for the record, I'm not Sauron.
And I'm not Frodo.
Thanks again to Professors Katie Atkinson and Andy Cooper. It's been really fascinating to hear about their work, and I really appreciate them spending time with us in their busy schedules. So that's the view from two professors at the University of Liverpool. In the next part of this episode, we're going to meet early career researchers Gabriella Pizzuto and Jack Mumford. Jack focuses on the development of AI and the law, and Gabriella explores the next generation of robotic scientists. Clearly, AI will play a huge role in their work. So I sat down with them both to find out about the impact it's having on their academic research now and what our relationship with AI may look like in the future. Nice to meet you, Gabriella and Jack. So firstly, can you briefly tell us what your roles entail at the university? Gabriella, if you want to take it away.
Hi, I'm Gabriella and I work as a Royal Academy of Engineering Research Fellow, and I'm also a newly appointed lecturer in robotics and chemistry automation. So basically I work on a research fellowship for the next 5 years, but I'm also slowly starting my group as a lecturer in the field.
Excellent. And yourself, Jack?
Well, I'm a research associate in AI and law. My work mainly focuses on legal reasoning. You spoke with Katie earlier. My work is focused mainly on the European Court of Human Rights. And what we've been doing there is giving the facts of a case to an AI system. And the AI system's job is to basically take those facts and try and predict an outcome, but in an explainable manner so that it is grounded in the legal principles that govern that particular domain. And also, as part of the role, I guess my main focus has been actually working with law students. So we've been running lots of research projects, which has had them read the cases first in a human eye to build these rich data sets, which are really crucial for being able to train and test the AI systems effectively, to be able to try and support that process when the court is trying to do the same thing in real life.
What was it that attracted you to AI and the legal side of it?
It depends how much you want to go back into my history with it, but I was first attracted because I was just working at a bank, and that was very much part of the sort of status quo. And sort of going into the field of AI, to me that symbolises the perfect intersection of innovation but also identity. So if you think about it, we understand ourselves better when we explore artificial intelligence because we understand kind of our place in the universe as well. But also it has wonderful implications for impact. We can actually truly drive progress forward, and that really excited me in a way that just simply working at the bank didn't. And I went and did an undergraduate degree in mathematics, and that gave me the tools I felt I could then use to go into AI and actually put that into real practice. And law, I suppose, if you put the law side of things, I mean, law is kind of the code by which human society could be said to kind of function, how it exists and how it thrives. It makes sense that artificial intelligence as a system and law as a system can sort of like kind of combine really effectively. It is a wonderful application of AI for me, quite exciting.
Excellent. So on to you, Gabriella. Clearly AI will play a huge role in your sector over the next decade. How are you using AI at the moment in your research?
Yeah, so we work mostly on the embodied AI side since we work with robots. So the idea is that traditionally in automation, robots are pre-programmed to do a simple task or specific task. And they go through the motions without thinking about the environment, perceiving the environment, interacting with the environment, and they get feedback back. So what I'm particularly interested in is having these robotic systems that are learning-based, so they learn through interaction with the environment. And I think in terms of using AI for such robotic systems, especially in my work, we look at the robotic manipulation side. So the robot learns how to do skills that humans are able to do. And this is really important, for example, in chemistry labs, because we want the robots to be deployed in human environments. So they need to be able to carry out the same tasks as humans are able to do that. We look at different forms of AI. Most of it are black box, but I'm also interested in adding physics into the machine learning models. And I think this is important because traditionally there has been a lot of work on this field, so trying to bridge these control methods that are more relying on physics fundamentals and with the data-driven methods. And I think this is the strength of bringing both fields together.
Brilliant. So you're both early career researchers. What do you enjoy most about your roles, and why the world of research?
So I think it's a job as an early career researcher that it gives you the flexibility and freedom to explore topics which I think are interesting or important for society. But the nice thing is you have flexibility and freedom. So the days are dynamic. I'm also excited in working with students. I'm also with my group, growing them, seeing where their research goes as well. So you have the chance to mentor people, but at the same time you develop also your research direction. I'm also very lucky to be on this fellowship, so I have plenty of time to focus on my research as well. And I think it's really exciting because of you're still growing in your research, and you're still in a position where you're figuring out the research directions to take. So it's exciting because it's all new. It's still not really, it's not boring, right? Because you haven't been doing it for quite a while. So I think it's really nice that we're starting everything, and everything is coming together.
Brilliant. And yourself, Jack?
Yeah, I really appreciate what Gabriella just said. I think that one of the things I often think is that when you said about everything being new, it's really a crucial aspect of research. That's what makes it exciting. And one of the things I compare it to actually is when you're driving a car, and when you're going somewhere you don't know, you've never been there before, and you have to really concentrate, the journey can often seem to last forever. But when you are driving somewhere that you do regularly, you can often have bits where you're home before you know it or something. And it's because you're not concentrating. And the more in new information you are, the more new situations you are in, actually kind of you have to pay attention. You live longer, bizarrely. You're actually living life by experiencing new things. When you are just going through the usual patterns, it all kind of blurs, and it's over before you know it. That's when people talk about lives slipping by. It's generally because they're forming into patterns of living, and you're then in automatic mode. And we actually see that with AI as well. It's part of the reason why training is more intensive than testing a system, is because the AI is having to learn. So its competition is more intensive, it takes much longer. When you're testing, you just throw it through the algorithm and out pops the answer much quicker than the training began. And that's a parallel to humans as well, that when we're learning, when we're encountering new things, we're living more. And that's a massively important part of research for me. And just for me personally as well, I suppose it's the same for you, Gabriella, that I really like to work in interdisciplinary environment of AI and law, because we're all obviously individuals and we're all different, but you do see there are differences of perspective that different disciplines sort of bring. And computer scientists do think, generally speaking, a bit differently to law academics and law students. And I really enjoy working with law academics. It kind of broadens, gives you a much richer experience. And I really like being able to work with students as well. I think particularly in research, you get the best aspect of working with students because you've got these really motivated people that are excited to be part of something new. And that's a part that I never want to lose.
Yeah, and I think we're also in a privileged position where we get to learn new things every day or every week. So I think that's also unique about our jobs. When you're doing the kind of job that we're doing, you learn basically every day. So that's really exciting.
Definitely, and I think that's probably one of the reasons I choose to work in universities for the last 20 years, to learn from the environment around me. Finally, what impact would you like to see from your work? Gabriella, if you'd like to go ahead.
Yeah, so in my field specifically, so I work in robotics for chemistry. So I think the field has been accelerating in the development, especially with the use of AI methods. I think what I would like to see would be to have robots in chemistry labs that go beyond sample transportation. So right now, robots are very good at moving things from one place to another. But I think we can do so much more with the robots that we have. So I would like to have the robots have the same or similar or at least more advanced skill level than what they have now, and probably start converging to what human chemists can do. So having robots that are capable of doing more skills and more tasks in laboratory environments, I think that would be really exciting if we move closer to that goal.
And there will, of course, be some other jobs for human chemists as well, because someone will need to manage those robots, program them, evaluate them, etc.
Yeah, definitely. So Andy talked a bit about that. So when we think about robots in chemistry labs, we always think about robots doing the repetitive tasks, doing tasks, maybe handling materials that are not safe for humans. So I think the humans should be focused on more mentally stimulating tasks that are more creative by nature, that are not as repetitive as the tasks that the robots are carrying out. So what I mean about having the robots have the same skill capability is more for the repetitive everyday task. In a chemistry lab, students, researchers, and overall the scientists, they spend a lot of time synthesizing new materials, which means that it's like baking a cake, basically. You add a lot of things together. You don't get the fun part about tasting the food, but you make some material, it might not even work out, so you go back to the drawing board. So it's a lot of repetition like that. I think robots should be able to help with that more. So that's what I meant. But of course, the humans are very much important. And there will always be a more interesting role, I think, than doing this repetitive tasks.
And Jack?
Yes, I mean, that absolutely definitely applies to law, of course, as well. There's absolutely no way that we can replace humans as part of the process in law. You cannot. There are certain aspects of AI where maybe you aren't too worried about the human oversight or explainability, but justification, the ability to have things grounded in the law and have human oversight are crucial. I think it depends on the time frame of when you ask the question, what I'd like to see from the work. I'd say in the short to medium term, what we've been working on is with this legal reasoning, with legal cases with the European Court of Human Rights. We'd like to create support tools that help the court practitioners summarize cases effectively, more efficiently, and also maybe serve as a proofreading tool in the same way as people nowadays use maybe a spell check or something like that to just check their words are spelled correctly and then tidy their grammar. We could do legal almost spell checks, as it were, where they are checking that everything is done in accordance with the law and in accordance with the requirements of the specification. Now, going forward, we can extend it to more judiciaries across the world, because the courts around the world are facing enormous backlogs. There's certain ones that enter the mainstream news, like, for example, our immigration claims backlog. And there are ones that are perhaps less politicized, which you can actually help support the court, make these, as Gabriella said, these more, say, repetitive tasks much more efficient, much more effective. That's, I think, what the role of AI is in the foreseeable future, to make these tasks much more streamlined so that the professionals can get on with more challenging and creative tasks.
Yeah, 100%. Well, thank you very much. It's been really great to talk to you, Gabriella and Jack, and we look forward to following your research and, of course, how you're all, working together and changing the world for the positive.
Thank you.
That brings us to the end of this episode of Original Ideas. And thanks again so much to our guests. You've just heard from Dr. Gabriella Pizzuto and Dr. Jack Mumford. And before that, Professor Andy Cooper and Professor Katie Atkinson. Some really interesting thoughts on AI and how it's shaping research and the wider society. If you'd like to find out more about anything you've heard in this episode, head to liverpool.ac.uk/research, where we also invite you to sign up to our monthly research newsletter, which includes updates on events, news, and fantastic opportunities to work with us. And please do subscribe to the Original Ideas podcast to get the latest episodes as soon as they're released. Thanks for listening, and talk to you again soon.